All right. Good morning, everybody. So, how are you guys? Kumusta? Or may galit kayo sa akin kaya hindi kayo sasagot? Because I saw the submission bins for the problem set, and it seems that dalawa pa lang yung nagpapasa ng 1.1, isa yung nagpasa ng 2.2, and then there are three who answered the 1.3, right? Kailan nga yung deadline natin? Tomorrow pa naman, no? So, yeah, you still have time. So, yeah. Kumusta naman? Or ayaw niyo talagang pag-usapan? Sige, moving on. So after we do the problem set, I would love to hear how you think about it, so that again, as usual, if we if you feel that it's too long, just let me know. Though I think it's just fair because it we only have three problems. Kaya lang baka ang maiisip niyo naman ay sir, tatatlo yung problems kaya tapos medyo kung three na nahirapan or feeling nyo tricking isang problem, so 30 points, mahirap magkamali ng isa lang, right? So yeah, I'll solicit your thoughts on the problem set hopefully soon after the reading break. Okay, and then what else? Yeah, I hope you can finish it by tomorrow. So for today, we'll start a brand new unit for the course. Actually, I was thinking if I will call it or I will declare today a holiday for us. But I ultimately decided super late kung ngayon ko pa ika-cancel yung meetings. So yeah, I'll just push through with it. And let's try to start the chapter, or the new chapter, which is about the solving systems of linear equations in a kind of a lightweight fashion. So medyo magaan lang yung topic natin for today. I saw Chasel's chat saying na maraming requirements. Yeah, I understand that because that's the tendency for teachers. Naghahabol kami ng requirements before we go to the reading break, all right? Because we don't want to ruin your reading break, but in the process, we are ruining the week before or 2 weeks before the reading break. But I don't think we have any choice. But yeah, so babawi na lang ako sa inyo. We will meet on the labs on April 11. That's Holy Monday. But we won't have a lecture on Holy Wednesday para tuloy-tuloy na yung bakasyon nyo after Holy Monday. All right. So, and then the exercise for Holy Monday will just be, I think, Lab Exer 2.2, which is just about underperformance of your root finding routines and instability. So I think madali lang siya. You still have your programs, I hope, with the root finding techniques. Tago niyo yun kasi magpapa-implement lang ako sa inyo ng ilan dun sa mga methods na yun. I'll give you some special functions na medyo makikita nyo yung underperformance ng methods o yung instability ng mga root finding problems. So, handa nyo lang yung mga programs nyo yun, and I guarantee you will not have a hard of a time answering XR 2.2. Okay? Now, um, dahil walang sumasagot masyado pag nangungumusta ako, no? So I decided to insert this sort of sharing my random thoughts for the first 5 or 10 minutes of the class, right? Para medyo hindi tayo diretso sa technical stuff, right? Pasensya na dun sa mga nagwa 155 this semester, medyo replay ito for you, okay? But I think this is a nice thought to share with you guys, especially with everything's going on. Kasi medyo pasaway din ako. Sabi ko, natitrigger ako pag nagbabasa ako ng mga comments or nanonood ng mga TikTok videos coming from this politically charged person. So, no, pero ginagawa ko pa rin, especially sa weekend, pag bored ako, walang magawa. So, nagle-lurk pa rin ako sa comment section. And there are lots of comments there, which are actually kind of fallacious, all right? And people are probably either intentionally doing it for their own agenda, or they are not just aware that it is fallacious, all right? So halimbawa, meron ako nakita sa Facebook probably a couple of years back, and this is a nice interesting story, and this is during the Second World War. In usual wars, whenever the two competing powers are at the same technological levels of technological levels, usually na measure yung mananalo dun sa isang war by looking at their weaponry, how much of their Class A weaponry survives the war, or kung paano sila paano nila nasusuportahan yung troops nila on the ground. That's why one of the outputs or products or byproducts of the Second World War is operations research. So shout out sa mga QMDS dyan, so or OR majors, right? So operations research was usually employed, or at least the modern version of operations research was deployed during the Second World War to optimize the processes. So specifically, the United Kingdom would like to develop some optimal process to supply their troops on the ground with food, uh, ammunitions, and so on. So kaya nag-optimize sila ng mga processes. And then one story doon naman sa US side is they were thinking of how to improve their planes para mapataas yung survival rate. So the US military did this study. Ang ginawa nila, pinag-aralan nila yung mga planes na bumalik after being deployed in battle, right? So padala sila ng airplanes, tapos syempre laban-laban sila. So they will sustain some casualties. And then what they did is to examine what happened to those airplanes that came back after the battle. Kasi ang gusto nilang tingnan, paano natin lalagyan ng armor o paano natin i-reinforce yung body ng planes natin um, para mas mag-survive sila, right? So, isang typical autopsy ng isa sa mga planes nila ay ito. So, nakita nila yung mga red dots dyan, ayan yung mga bullet holes. Okay? Dyan tinamaan yung mga planes. So, they first thought of, okay, so mukhang maraming tama yung airplane dito sa wings, tapos sa midsection, and then sa tail. So they thought of, why not put extra reinforcement on these parts of the plane? All right? Lalagyan nila ng armor kasi hindi efficient na lagyan nila yung buong airplane ng reinforcement. Number one, that will be very expensive. And number two, that might affect the performance of the airplane. So tingnan nila, saan tayo kailangan mag-reinforce, right? So they thought of, yeah, let's do this. Let's reinforce these yellow spots here because that's where our planes sustained heavy casualties, right? Now, merong isang mathematician by training, and it is Abraham Wald, okay, who said, hold on, parang mali yung idea na gusto niyong gawin. All right? So, ano sa tingin niyo yung naisip ni Wald? Which I think is a nice illustration of how mathematicians think outside the box. Because if you will be thinking about this problem, you might conclude, at least without thinking about it too long, mako-conclude mo na, mukhang tama naman, maraming bullet holes dyan. So yan yung tapalan natin ng mas makakapal na bakal, alright? But sabi ni Wald, hold on, parang mali yung argument. And Charles is right. So yun yung sabi ni Wald. So hindi nila kinonsider yung mga planes na hindi nakabalik, alright? Because these planes, despite having sustained injuries at these parts, were able to survive, go back to their base and be repaired, and they will be ready to be set out again, say in a couple of days or a couple of weeks, right? Ang hindi nila nakita ay yung mga hindi nila na consider yung mga planes na hindi nakasurvive. So Wald said, wag dyan yung reinforce natin kasi nakaka-survive sila kahit may tama sila dyan. Why not let's reinforce, say here, towards the engines or towards here. Kasi yung mga planes na hindi nakabalik, sila yung malamang yung tinamaan dito sa mga red spots and they were not able to survive because of that. So if we will reinforce our planes in the red regions, then hindi tatamaan yung vital spots. All right? And this idea of Wald was adopted by the US military, and it increased the survivorship rate of their planes. Okay? And this phenomenon that Wald first observed is called survivorship bias. Survivorship bias. Wherein in some situations we tend to just take a look at the successful individuals. Sino yung mga nag-survive sa isang selection process, or basically those who survive a tragedy. And we're trying to infer from the experience or from the traits of those who survive, um, some possible ways on how to increase the survivorship rate. So, pero mali. Ang problema rito, hindi natin nako-consider yung mga traits na meron or wala dun sa mga nag-survive. So basically, we are silencing down or we are not giving voice to those who did not make it past that natural selection. So if some era was good to you, that doesn't mean that that is good for everybody. So and I know that a lot of people are guilty of survivorship bias nowadays, because if we will just ignore the experience of those who are unfortunate not to make past a certain period of time or a certain tragedy, then we are doomed to repeat history. Okay? So, yun lang yung gusto kong i-share for today. So, thank you for listening to my podcast. All right. Pero yeah, it's a nice thing to share with special with you guys, especially you are aspiring future mathematicians, right? Okay. So, tama na yan. Okay, so dahil pasaway ako, all right, I don't know why, but yesterday I planned to do module number or to write module number 6, pero I went on a sleeping spree. So parang 8 p.m. yata tulog na ako, nagising ako kanina ng 3 a.m. Pero nung nagising ako ng 3 a.m., nanood lang ako ng ilang videos. Then natulog uli ako at around 4. Tapos gumising ako around 8 or 9, all right? So I didn't really have time to write the module in latex format. So medyo kakaiba. Temporary muna itong module number 6. But I'll take advantage of the reading break and the Holy Week to type this up in latex. So hopefully okay lang sa inyo. Or sana nga maging okay na sa inyo kahit handwritten. Isa kasi sa problema ko, wala akong motivation to write module number 6 kasi alam ko yung chapter na to ay puro matrices. And for those who know how to write in latex, napakahirap talagang mag-type ng matrices sa latex. So parang yon, na-discourage na ako noon. So handwritten na lang muna tayo ngayon, guys. All right? So I hope that's fine. I already uploaded this in Canvas. So ganun siya makita. Pero yun nga, I'll insert some things along the way. Hopefully I didn't forget things. So the next unit of the course is about solving linear equations. And this is very important because number one, systems of linear equations are actually, they actually arise in most physical and natural phenomena. Kasi most of the phenomena that we have in nature are either linear or sila ay kayang i-approximate by a linear system. So if you recall, halimbawa, yung sa calculus na lang, we have derivatives and we have integrals. And remember, both of them has a linearity property. Ano yung linearity property? Ang derivative ng sum ay sum ng derivatives. Ang integral ng sum ay sum ng integrals. Tapos ang derivative ng scalar multiple ay scalar multiple ng derivative, and the same thing goes for integrals, right? So that's what we call the linearity property. And if your operator has the linearity property, okay, then it can be modeled via a linear system. Okay? So pwede kang bumuo ng isang linear equation or system of linear equations from such linear operators. And you know, integrals and derivatives are often the tools that we use in order to describe natural phenomena. Paano nagpropagate halimbawa ang sounds, right? So ano lang pala siya, superposition lang siya ng mga sinusoidal waves of different magnitudes or different scales. What else? If you're solving ordinary differential equations that model real life phenomena like epidemic or pandemic spread. Ano pa bang ginagawa natin sa ODE? I hope you guys have taken 151. Ano pa nga ba? Or have you guys taken AMAT 105 or Math 120? So hopefully you have seen their different applications ng linear systems. So napaka-importante niya talaga. Tapos pag meron kang isang phenomenon na hindi describable via a linear system, there are some ways on how we can linearize these processes para yung solution dun sa komplikadong say non-linear partial differential equation ay kaya nating maibaba into solving a linear system. Siguro isang elementary example sa pag-solve nyo ng system of ODEs. Kung nag-math 151 na kayo, kapag ka meron kayo say second order system, meron kayong system of second order ordinary differential equations, pwede mong gawin, kunin yung Laplace transform nung both sides ng mga equations. Tapos, pag kinuha mo yung Laplace transform niya, nagiging isang linear system na lang siya. And solving that second order system of ordinary differential equations boils down to solving a linear system. Okay? Tapos, paano nga ba isosolve yung linear systems? Of course, there are some ways para ma-solve siya. Nakita nyo na yung ibang paraan or may at least tatlong paraan na kayong alam. The first one is Gaussian elimination. Ito yung elimination process na nakita nyo sa elementary algebra. Pangalawa ay yung ano pa ba? Yung substitution method wherein you express one unknowns in terms of the other unknowns and then try to manipulate and use these equations on one another to ultimately come up to ultimately find the values of at least one of the variables tapos magsa-substitution ka na lang ulit. Tapos yung pangatlong paraan is via Kramer's rule, which involves finding the determinants of the matrices. All right? Yung batch nyo ba, naabot nyo pa ba yung Math 17 or hindi na? Ayan, generation gap na, no? Kayo ay batch 2018 nga ba? So yeah, so hindi nyo na naabot, no? Okay. So pero sa senior high, sana nakita niyo yung methods of solving linear equations, at least yung mga 3x3. Tama ba? Kasi dati nung sa Math 17 yung algebra and trigonometry, merong isang unit devoted to solving linear systems. Pero ano lang naman siya, elimination, substitution, saka Kramer's rule. So nakita niyo siya nung high school? Gusto ko malaman kasi para malaman ko kung paano ko i-approach yung discussion sa chapter na to. So wala na kayong ganun nung senior high pag ABM? So hindi kayo naka-encounter ng equation like this kung paano siya sinosolve? High school, elementary, or familiar kayo pero hindi nyo ma-pinpoint kung saan nyo siya tinig? Junior high pa. Okay, that's fine. So, paano ba to? Okay, so yun yung tatlong methods. Pero ang gagawin natin, elimination and substitution. Thank you, David. Yeah, yung Kramer's rule ay hindi nyo pa nakikita. So probably I'll mention Kramer's rule probably for the sake of those who haven't seen it yet, all right? Pero kasi yung problema dun sa mga methods na yun like substitution, Kramer's rule, ay medyo mahal sila computational wise. So ibig sabihin, or computation wise, maraming operations yung involved. So in this chapter, we're going to look at some methods that are efficient and in the sense that they only involve little operations, arithmetical operations. Number two, that they are stable enough to be performed on machines. Ibig sabihin, di sila ganun ka-sensitive sa round-off errors and machine truncation. Tapos, titingnan din natin ano yung mga pwedeng remedyo kapag ka-ill-conditioned yung problem. So, in this particular module, we'll try to talk about yung Gaussian elimination, which is basically the elimination method na natutunan nyo hopefully from junior high or from your elementary algebra courses. Okay? Tapos, sabihin ko mamaya kung bakit mas advantageous ito kaysa dun sa ibang mas dun sa pang elementary methods. Okay? So, let's start our discussion by recalling how a system of n linear equations look like. And that's what you'll see here in equation 1. Okay. So, bawat isang equation, meron tayong n equations. So, and then each of the equations only has linear terms. Tapos, meron tayong n unknowns. So, the unknowns here are x1, x2, x3, and xn. Tapos, meron tayong constants b1, a11, a12, a13 hanggang a1n. All right. So, they are constant real numbers the exabytes are our unknown, and we have n such equations. So meron tayong n na unknowns, and then we have n equations relating these unknowns to each other via some constants. Alright? Tapos, dito nyo malamang in-apply yung elimination and substitution nung high school. Kung meron kang 2 by 2, alright? Bigay ba ako na? Sige, kung meron kang 2 by 2 system, hold on. Kopyahin ko pala muna to. Okay. Para pagka in-update ko siya ay hindi kasama yung annotations ko. Alright, so halimbawa meron kang 3x plus 5 equals 7. Tapos meron kang, madali na lang, x minus 3 equals negative 2. Alright, yung elimination process ang ginagawa natin ay nagmo-multiply tayo in either of the equations or both of them by a constant so that when we add them, at least one of the unknowns will be canceled out. Dalawa nga pala dapat yung unknown. So ito ay isang example ng 2 by 2 system. So gusto ko halimbawa may eliminate muna si x. So mawala si x mula dun sa picture. So we know that adding multiplying an equation by a constant doesn't change its or multiplying both sides of an equation won't change the solution to that equation. And then adding two equations or adding another equation to another equation won't change the solution to the equation. So doon tayo nagka-capitalize sa elimination process, right? So here, maybe I can plan to eliminate the variable x and I will perform those elementary operations. Unang elementary operation probably is to multiply both sides of the second equation by the constant negative 3. So again, multiplying an equation by a constant doesn't affect the solution. So I can do that. I'll multiply the second equation by, say, negative 3. And you will see later why I chose to do so. Multiply everything by negative 3. So ito magiging 9. Tapos ito ay magiging positive 6. All right? And then adding equations won't change the solution. All right? And that's why I chose to multiply the second equation by negative 3. So that when I add the corresponding sides of these two equations, the terms with x will just cancel each other out, right? So I'm going to have 3x minus 3x. That goes to 0. That's what we meant by eliminating a variable. So x is out of the picture, leaving us only with a variable y, and we're expecting to get only one equation. All right? So we add this together, we get 14y equals 13. Hindi ko pinag-isipan yung system. Ayan, tuloy fraction yung sagot. And sino ba naman ang gustong mag-work with fractions, right? But I think I don't have a choice here. So the resulting system, with one less the number of variables from the previous step, is now easier to solve. So I'll simply divide both sides by 14 and get y equals 13 over 14. So yun yung kagandahan ng elimination. So 2 by 2 makikita mo na siya. Kung 3 by 3 yung system mo, you'll need to do the elimination process, but you'll need to eliminate one of the variables using a pair of those equations. So para from one 3 by 3 equation, magkakaroon ka na lang ng dalawang equations with two unknowns. Tapos mag-elimination ka hanggang makarating ka sa isang variable na. Alright? Now, kapag dito, nakuha mo na si y, you'll just plug in this value of y to any of the three equations that we have, which is the original first equation, the original second equation, or the scaled second equation. So yun yung mga options kung saan pwede kang mag-substitute ng y equals 13 over 14. So this is a variation of a back substitution because we have this value and we will substitute it back to one of the equations that we have before para ma-compute yung variable, yung isa dun sa mga unknown variables pa. So halimbawa, dito sa system natin, I'll do the back substitution on the first equation. All right. Oops. Lagay ko siya dito. Tapos gagamitin ko yung y equals 13 over 14. Equals 7. Okay. And then from here, I can solve for x. So we will have x equals what? 7 minus 65 over 14 all over 3, whatever that value is. All right. Kung 3 by 3 yung system nyo, Meron ka ng X, meron ka ng Y. So supposedly may isa pa missing variable Z. Hanap ka lang dun sa mga equations na meron ka, something that involves X, Y, and Z only. And then you do the back substitution again by plugging in the value of X, the value of Y, para dun sa equation mo, Z na lang yung unknown, you can compute for it easily. Kasi linear lang naman yung mga resulting equations. Okay? So ito yung idea ng elimination process. Okay? And that's what we will try to generalize here for the case of a generic n by n system. Gagawa tayo ng sistema. Okay? Kasi sa elementary algebra, usually 3 by 3 or 2 by 2 lang yung pinaglalaroan nyo kasi masyado ng matrabaho kapag ka 4 by 4 and you will not gain too much from it because it's just really a repetition though in a much larger scale of what you can do on the 3 by 3 or 2 by 2 system. But fortunately for us, hindi naman natin siya gagawin mano-mano kasi pwede natin itong i-program. So kaya nating mag-solve ng mas malalaking system, which is great because most of the processes in nature involves a lot of variables. Okay, lalo na kung nagli-linearize ka or nagmo-model ka from a continuous problem down to a discrete problem, kailangan mo ay tens of thousands of equations in, say, 500 unknowns. So, ganun kalaki yung mga systems na gusto nating i-solve. Right? But as I've mentioned, we'll start from the basic and try to first look at the usual elimination process in a different way na medyo mas apt for machine implementation. Kasi parang dito sa elimination ng high school, medyo timplahan to. Kasi tayo yung pipili, ano yung magandang pang-multiply para ma-avoid yung fractions and so on. Ang problema sa computers, hindi sila creative. Kailangan natin silang sabihan exactly kung ano yung gagawin para ma-eliminate yung mga variables. So there's no room for them to be creative. Kailangan nating idikta ano yung i-multiply mo, sino yung pag-add mo, and so on. Okay? And having said that, hindi madaling ipagawa yung elimination process sa kanila in the same manner as kung paano natin sila ginagawa manually. Kasi nga they are just following our instructions. So hopefully today I'll be able to give you an idea how to ask computers to do the Gaussian elimination method. Right? So by the way, itong elimination method na to, ang mas formal name niya ay Gaussian elimination to differentiate it from the other elimination processes. All right? Okay. Now, how do we do this? So first we translate the system into its matrix form. Ang matrix form niya yung nasa equation 2, which is AX equals B, where A is an n by n matrix. So I will denote the set of all n by n matrices with constant entries, with real entries as this set, M sub n of R. Usually, susulat ko yan na n by n, all right? Para alam kung ilan yung rows at ilan yung columns ng matrix, okay? Pero kapag ka n by n naman yung matrix, pwedeng isang number na lang yung ilagay nyo na subscript, okay? So this means A is an n by n matrix with real coefficients. Tapos ang laman ng matrix A dito sa equation 2, right? Etong matrix A na to, siya yung tinatawag na coefficient matrix wherein you just collect the coefficients of the unknowns in the right order into the matrix. So halimbawa, ang ordering natin ay common among all of the equations involved. Nauna si x1, si x2, si x3, si x4, at si xn. Pag ifo-form mo na yung first row ng coefficient matrix, you will simply harvest the coefficients of the first equation. So A11, A12, A13, and A1n are the coefficients on the first equation. So they will live on the first row of the coefficient matrix. And we will do this in order, meaning the first coefficient, or I mean the coefficient of the first variable in the ordering that you chose, should be the first entry in the first row, the second coefficient, the second entry in the second row, and so on. Okay, so kailangan consistent kayo dun sa ordering. Make sure that the x sub 1s are the first in all of the equations. X sub 2 or the x sub 2s are the first variables in all of the equations you have, and so on. Dapat consistent yung numbering. Okay? And then, yun yung matrix of coefficient or the coefficient matrix A. Then usually we write it as this bracket symbol with a bracket symbol here. Sometimes you use parentheses, so it's just a matter of taste. And then sometimes I will denote the matrix by just this, A sub ij in parentheses, para sabihin, ito yung matrix ng entries niya ay ij. Perhaps I should use brackets. Brackets na lang pala, para consistent na bracket to bracket yung matrices ko. Okay? All right, then in equation 2, going back, the x that you see here is basically the vector of unknowns. It's an n by 1 matrix. Ito yung itsura, x1, x2, xn, all right? In the same order as they appear on each of the equations, all right? So siya isang n by 1 matrix with real coefficients. So sila yung mga values ng mga x sub I, sila yung gusto nating hanapin. And then lastly, the vector B is another n by 1 matrix consisting of the right-hand sides of each of the equations. Okay? Now, parang walang sumagot pala nung tanong ko kanina. Sino yung nakapag-linear algebra na? O nakapag-matrix theory na? Well, Math 105 or Math 120? Lahat ba kayo? I suppose so kasi at least junior na kayo, tama? So alam niyo na yung matrix multiplication, matrix addition. Okay, so hindi ko na siya babalikan, alright? So, yeah, thank you, David. I'm at 105. Currently taking Math 120, but hopefully you're familiar with matrix operations, so hindi ko na siya dadaanan, okay? All right, some special types of linear equations. Kapag yung right-hand side vector o yung vector of constants b natin, ang laman niya ay puro zeros, ang tawag natin doon ay isang homogeneous system, all right? So if your right-hand side are all zeros, then that's called a homogeneous system. Otherwise, it's called a non-homogeneous system. And then in future discussions, we will talk about solution schemes that works best for homogeneous systems or non-homogeneous systems, or what are the implications of solutions of homogeneous systems or not. Depende pala dun sa mga methods na ma-decidean ko na i-discuss. Pero I hope you discuss the implications of homogeneous system and non-homogeneous systems in 120 or AMAT 105, okay? Pero terminologies lang, baka later kasi mag-pop up kaya gusto ko siyang sabihin dito. Tapos i-recall natin yung Gaussian elimination, yung ginawa nga natin, yung ginagawa nyo nga nung high school. But before doing that, let me present to you a theorem which is, I think, is usually given in AMAT 105 and Math 120 as one of the elementary results sa linear systems, okay? So kapag meron kang linear system of the form equation 1, yung mahabang equation natin, tapos ang matrix form niya ay yung nandun sa equation 2, which is ax equals b, then the following statements are equivalent. Right? First statement, kahit ano pa yung right-hand side vector, we will always have a unique solution vector C that is also an n by 1 vector in R or n by 1 matrix in R. So, yun yung first statement. Kahit ano pa yung right-hand side, laging may unique solution. Okay? Now, that is equivalent to the statement that the homogeneous equation 2, that means the right-hand side of equation 2 is set to all zeros, then we will have a unique solution. And that unique solution will be the zero vector. So, yung first statement ay equivalent dun sa statement na yung homogeneous equation ay nag-iisa lamang yung solution. Solution na puro zeros yung values ng variables. Okay? And then these two statements are equivalent to saying that A is non-singular. That means the inverse of the matrix A exists. Ano nga ba yung matrix A inverse? Yung matrix inverse is the unique matrix such that AA inverse ay equal kay A inverse A ay equals sa identity matrix of dimension n. All right? So, yung A inverse, sino yung i-multiply mo kay A para makuha mo yung identity matrix? All right? So, kapag unique yung kapag may unique solution yung system mo, you are sure that A inverse exists. Or the other way around also works. The converse works. Kapag nag-exist yung inverse, then meron kang unique solution. Actually, pag nag-exist yung inverse, madaling mahanap yung unique solution because if you start with AX equals B, tapos alam mo na siya ay non-singular, then by theorem 6.1, you know that there exists a unique solution. And actually, you can do more than that. You can solve for the unique solution by just applying A inverse to both sides of the equation. So you multiply A inverse to the left of the corresponding sides. Okay? Tapos gagamitin natin yung associativity ng matrix multiplication plus the fact that A inverse times A equals the identity matrix. Okay? Pero yung identity matrix times any vector of the appropriate dimension will just give the vector back. So ang identity times x ay equal lang kay x. So x equals A inverse B. So this will be our solution C. Yan yung unique solution na C. But so isipin nyo, sir, edi madali lang pala mag-solve ng linear system. Kunin mo yung AX equals B, tas multiplyan mo both sides of the equation by A inverse, then you should be done. All right? But I'll mention later why this is not an efficient process. Okay? So, but yeah, it's good to keep this theoretical result in mind. And then another result that is equivalent to the previous three statements is that the determinant of A, denoted either by det A or just the absolute value of the matrix, is non-zero. Pag non-zero yung determinant, then alam natin na siya ay non-singular. Ibig sabihin nag-exist yung A inverse. And so it follows that the linear system of the form 1 or 2 will both have a unique solution. Okay? So babalikan natin yung consequences ng theorem 6.1, but this theorem is very basic na hindi ko na pwedeng na ayokong patagalin yung pag-i-introduce sa kanya. And by the way, if you have taken Math 105 or Math 120, you probably have seen this as one of the elementary results in the course. Okay. Now, this is what I promised. We will try to go back to Gaussian elimination and look at it from a matrix perspective. All right? Kasi dati siguro sa high school wala pang konsepto ng matrices. So nagano lang kayo, nag-multiply ng appropriate scaling constant sa isang equation, tas nag-add kayo, tapos nawawala yung isang variable and so on. Ngayon, gawin natin siya in a matrix format. Okay? Now, this is done by performing what we call elementary row operations. So if you haven't taken the linear algebra courses, then ito lang naman yung ibig sabihin ng elementary row operations. Pag given ka ng isang matrix A, isang n by n matrix A, then meron tayong tatlong klase ng elementary row operations. Una, we can interchange row I and row J, and we will denote it by this notation. Okay? Pagpalitin mo lang yung rows. Ang kagandahan sa elementary row operations, hindi niya binabago yung solutions dun sa system. Okay? So this is quite easy to imagine, or I mean how the first operation will not alter the solution to your system. Kasi pinagpalit mo lang naman yung pwesto ng equation I at saka equation J, all right? Because basically that's the consequence of interchanging the rows of your coefficient matrix. And the ordering of the equations in the system will really not affect the solution to the system. Okay? So kaya okay lang siya. Isa siyang elementary row operation. Second elementary row operation is to multiply a row by a non-zero constant. And again, alam natin na pag nagmumultiply ka ng non-zero constant sa isang equation, hindi nababago yung solution. And that is inherited by linear systems. And the third one is basically what we are using, or what's the justification for doing the elimination process. Because adding a multiple of a row to another row preserves the solution to the system. So pag halimbawa yung row I, gusto kong palitan by the sum of row I plus a multiple of a previous row, say row J, okay? Hindi mababago nito yung solution ng system, okay? So this just means I am adding to row I the C multiple of row J. Okay, so mababago yung row I. So, and then what we'll do is to apply elementary row operations on the augmented matrix so that we reduce the system into an upper triangular system. Ano yung ibig sabihin natin ng isang upper triangular matrix? Ang isang upper triangular matrix ay isa lang matrix, isang matrix U na ang Uij, ang entry niya sa ith row and jth column ay equal kay 0 kapag yung row number ay mas malaki na sa column number. So basically, ang itsura ng isang upper triangular matrix ay ganito: A11, A12, A13 hanggang A1n. Okay? Tapos yung diagonal entries, A33 hanggang ANN. So here, meron tayong mga constants, alright? Pero kapag yung row number ay mas malaki na sa column number, for instance, this is supposedly A21. It's on the second row, it's the first column, the row number is greater than the column number, so ito ay magiging equal kay 0. And then ito ay magiging 0 rin, yung mga narito. So everything under the main diagonal will have a 0 entry, okay, in an upper triangular matrix. Kaya siya upper triangular kasi yung mga non-zero entries posible lang mag-exist dun sa upper triangular half nung square formed by our matrix, right? So pwede mo to kasing isipin ng isang matrix sa isa lang rectangular arrangement ng mga numbers. So kapag dun sa rectangular arrangement na yon, yung mga non-zero entries ay nandun lamang sa upper triangle along the diagonal, then it's an upper triangular matrix. So lahat ng entries sa ilalim ng main diagonal ay nag-i-equal na kay 0. Usually, sinusulat lang natin to as isang malaking 0 dyan. So, yan yung upper triangular matrix. So, yung ginagawa natin basically sa elimination process, dun sa Gaussian elimination. Kasi ang ginagawa natin doon, binabawasan natin yung mga equations dun sa system. So, parang dito sa huling entry, isa na lamang yung unknown. Kasi pag binultiply natin to dun sa vector of unknowns, alright, makikita natin na yung last row dun sa product. So basically, ito mamumultiply by this guy, magkakaroon lamang tayo ng ANN XN equals whatever the right-hand side is. Tawagin ko yung right-hand side, halimbawa na D sub n. So ito yung nangyayari dun sa huling proseso, dun sa elimination process natin ng high school. Isa na lamang yung variable na natitira. Tapos, ang ginagawa natin, nagba-back substitution tayo. What do I mean by back substitution? Kasi di ba naghahanap tayo, pag nasolve mo na isang variable, maghahanap ka ngayon ng isang pang equation na dadalawa yung variables na involved. In our case, siya lamang yung susunod dito. Siya yung nandun sa second to the last row, because the second to the last row we will only have two non-zero entries, a sub n minus 1 comma n minus 1 at saka a sub n minus 1 comma n. Pag minultiply ko yan dito sa x1 hanggang xn, ang makukuha ko lang ay a sub n minus 1 comma n minus 1 times x sub n minus 1 plus a sub n minus 1 kasi nasa n minus 1 row ako, pero nth column times x sub n equals the right-hand side d sub n minus 1. And then ito yung tinatawag nating back substitution. So kasi dito nakita natin, alright, nakakita ko ng isang equation na dalawa lang yung unknowns. Alam ko na yung value ni x sub n, so I can plug in whatever value of x sub n I get from here. But that is essentially what? D sub n over ANN. Alright? Pwede ko siyang gamitin dito. Kaya back substitution yung tawag niya. So nagsimula ko dito, yung mga values na nakikita ko at every row, starting from the last row, ay ibaback sub ko lang doon sa previous equation. Magkakaroon ako dito ng dn over ANN kasi yan yung value ni xn na makukuha ko from the last equation. And then you see here that initially we have two unknowns, but after substituting all the known values, in this case we only have one known value, isa na lang yung matitirang variable. Okay? Tapos, di ba, sa substitution, ang susunod yung gagawin, alam ko na yung dalawang values. Alam ko na yung value ni x sub n minus 1 at saka ni x sub n. So, hanap ako ngayon ng isang equation na tatlo lang yung unknowns. Tapos, dalawa sa kanila dapat si x sub n minus 1 at saka si x sub n. Gagawin ko, isa-substitute ko sa kanya yung value ni x sub n minus 1 na nakuha ko at saka value ni x sub n na na-compute ko before to get x sub n minus 2. All the way until we get to the top, which has completely the n variables, pero alam na natin yung value ng n minus 1 sa kanila, so we can solve for the last variable, x sub 1. Alright? So yun yung idea kung bakit gusto ko siyang ibaba to an upper triangular matrix so that I can do the back substitution easily. Alright? So, do I make sense so far? Or masyado bang mabilis? All good pa naman? Huwag niyo munang isipin yung programming. Alright, so intindihin muna natin yung process. So now, I summarized here what is done in the Gaussian elimination process. So parang ito yung magiging algorithm natin. Ang input natin ay yung coefficient matrix, tapos yung vector of constants, alright? And the output is a vector C which solves the system or an indication na wala siyang solution. Okay? Now, ano yung mga steps na kailangan natin gawin? Una, we should form the augmented matrix. Alright? So ito yung mas malaking matrix formed by the coefficient matrix appended with the right-hand side vector. Okay? So this will now be an n by n plus 1 vector. N by n plus 1 matrix. And then what we'll do is to apply elementary row operations on the augmented matrix so that ultimately we will have this augmented matrix. Pero ang gusto ko ngayon, dapat yung n by n portion ng augmented matrix dapat ay upper triangular. Okay? Kasi pag upper triangular na siya, pwede tayong mag-back substitution. The first thing is we can find C sub n easily. That's just dn over un n, all right? But starting from n minus 1 down to 1, we can use formula number 5, which is basically your back substitution routine, all right? Now, there will be no solution if one of the UIIs are not equal to 0, okay? I doubt na kailangan ko to. I think I don't need that one. Ngayon ko lang naisip. Then we can say that the solution does not exist because basically you will have division by 0 over here. Or a unique solution doesn't exist. Para mas sure ako, no? Then a unique solution to 2 does not exist. Okay? So, utang uli ako ng 5 minutes. So, in the next 7 minutes, let's illustrate this, at least the Gaussian elimination process. Okay. Now, example 6.1. Binigyan tayo ng system 6. All right. It's a 4x4 matrix. Okay. So, kung high school pa tayo ngayon, ang gagawin ko dyan, kailangan ko mag-eliminate ng isang variable, pero para makapag-eliminate ng variable, kailangan ko siyang kailangan kong gawin to pair by pair. Alright? So, pwede kong i-pair si equations 1 and 2, tapos equation 2 and 3, tapos si equation 3 and 4, alright? Para sa bawat pares na to, alright, magiging tatlo na lang yung variables. So, pwede kong i-eliminate si x1 sa tatlong pairs sa mga to. So, the result of the first elimination pass will be a 3x3 system. 3 equations and 3 unknowns. Tapos, ipag-prepare ko na naman sila, marireduce ko yung 3x3 na yon into a system of 2 equations and 2 unknowns. Tapos, gagawa pa uli ako ng elimination para isang variable na lang yung matitira. So, that's what we could have done kung hindi pa natin alam yung elementary row operations. But now we can take advantage of elementary row operations to do the Gaussian elimination in probably a more efficient way. Okay? So how do we do this? All right. So transform first your system into its matrix form. So I simply harvested all of the coefficients and put them into the coefficient matrix A. And then all of the right-hand sides were written inside the vector of constants. Okay? And then next step, form the augmented matrix. So I'll just simply put these two matrices side by side. So kung 4 by 4 ito, tapos ito ay 4 by 1, yung augmented matrix will be 4 by 5. And I will perform elementary row operations on this augmented matrix so that yung matrix dito sa kaliwa ng division bar, okay, o ng separation bar, ay magiging upper triangular. But remember, you need to treat this as a single row. All right? So kung ano yung ginawa nyo dun sa left part ng augmented matrix, isasali nyo yung nasa right side ng augmented matrix. Okay? Kaya natin siya ino-augment. Kasi dapat kung ano yung ginawa natin sa coefficient matrix should reflect a change on the vector of constants. Okay? Now, what I can do here is to choose a pivoting row. Pag sinabi nating pivoting row, ito yung row na hindi ko babaguhin. Alright? So, parang pag nagro-rotate kayo ng isang bagay, meron kang pivot point. Halimbawa, nagro-rotate ka ng isang bond paper nasa table mo. So, you put your finger on a point on the bond paper, tapos saka mo yung iikutin yung bond paper. So, the pivot point sort of acts as a fixed point, hindi nababago yung position niya relative dun sa ibang points dun sa bond paper na nabago na yung position niya after rotation. So yun yung pinapreserve natin. So in this particular case, in the usual Gaussian elimination process, I will pivot along on the first pass. I will pivot on the first row, meaning I will not change the first row. So I will affect all the changes on the second to the fourth rows so that I can achieve an upper triangular matrix in the end. Okay, so I'll pivot on the first row and then I'll do elimination on the first column. Because remember, I want an upper triangular matrix, so I want the entries here below the diagonal on the first column to all be equal to zeros. Okay? So yung gagawin ko. Now, I'll perform elementary row operations. Ano yung mga row operations na yun? Basically, usually ito ay adding a scalar multiple of the pivot row to the current row. For instance, look at R2. I want A21 to be equal to 0 para mapalapit ako sa isang upper triangular form. So I can think of how can I eliminate how can I eliminate the first entry in the second row by simply adding to the second row a multiple of the pivot row or the first row. Okay? So basically, 3 ito. So gusto ko mag-multiply sa kanya ng isang multiple ng first row na ang entry on the first column ay -3. Alright? So basically, ang kaya pwede ko palang gawin, i-multiply ito ng -3/4. Okay? Tapos i-add yung result na yon dun sa second row. And whatever the answer is will be my second row. So basically, that's what this statement is telling me. Alright? Dun sa ERO na to, yung R2 ay pinalitan ko ng R2 minus 3/4 ng R1. And if I do that, this is what I'll get in the second row. So basically, it's 4, dito muna tayo, 3 minus 3/4 times 4, that's going to be 0. Okay. Then 4 minus 3/4 of 3, I'll get 7/4 all the way up to the last column. So this will be 1 minus 3/4 of 1. So that's gonna be a quarter. All right. Tapos gagawin ko rin to dun sa third and sa fourth rows. All right. Pero lagi kong ginagamit ay yung pivot row. Yung pivot row siya yung minumultiply ko by the appropriate constant para mag-zero yung entries dun sa first column ng mga non-pivot rows. Okay. So in this case, I will replace R3 by R3 minus 1/2 R1. Ito yung makukuha ko. Tapos lastly sa R4, papalitan ko siya ng R4 minus 1/4 ng R1. Okay? So this is now our new augmented matrix, which will be subjected to the second pass of the elimination process. Okay? Second pass ng elimination process, we'll forget about the first row. Tapos na tayo dyan. Wala na siyang problema kasi pwedeng non-zero yung lahat ng entries niya. Okay na tayo dun sa second row kasi isa lang naman yung kailangan mag-zero sa kanya. Kasi nga below the main diagonal lang yung kailangan mag-zero. So we will elect the second row to be our pivot in the second pass of the elimination process. Okay? Kasi dun sa second pass ng elimination process, kailangan kong ma-eliminate ito at ma-eliminate ito. Kasi nasa ilalim na sila nung second diagonal entry. Okay? So again, what I'll do is to replace the third and the fourth rows by the respective row minus an appropriate scaling of the pivot row. So I'll need to find what should be multiplied to the second row so that when added to the third row, the entry on the third row second column will be equal to 0. Okay? So ito ay 7/4. Tapos yung 3/2 gusto kong maging 0. So magkakaroon ng 3/2 times a scaling factor. Gusto nating maging negative 7/4 dapat yung sagot. So si S ay negative 7/4 times 2/3. So that's how I get, tama ba? Or baliktad, 6/7. Baliktad pala. Dapat ang hinanapan ko, sino yung multiply ko kay 7/4, which is basically this guy, all right? Para maging negative 3/2. Para pag in-add ko siya dito, magzi-0. So there, I'll get negative 3/2 times 4/7. So that's gonna be what? Negative 6/7. And that's how I got that, right? So I need to multiply the second row by negative 6/7, add that to the third row, so that the resulting new third row will have 0 in its second column. Okay? And do the same thing for the fourth row. So fourth row naman, kailangan kong i-multiply ng 5/7. So negative 5/7 yung second row para ma-eliminate ito. Okay? And then you will not stop here because although we are fine with the first 3 columns or the first 3 rows, may problema pa tayo dun sa fourth row. Sa fourth row, kailangan mag-0 pa ito. Okay? But that's easy because what I'll do is to choose the third row as my pivot in the third pass of the elimination procedure, right? I hope you see kung bakit hindi na ako pwede mag-pivot sa second row. Kasi pag nag-pivot ako sa second row para ma-eliminate yung unwanted entries sa fourth row, okay? Ito ay posible maging most likely, siya ay magiging non-zero. Kasi mo-multiply mo yung second row by a constant, so ito ay mamomultiply ng isang constant. Pag in-add mo siya sa fourth row, magiging non-zero ito. Mawawala yung upper triangular effect na gusto nating ma-achieve. So that's why we usually pivot on the immediate row before the particular row na gusto nating mawala yung desired variables. Okay? Now, finally, we get this result, okay? And we're happy with this because you see the matrix on the left part of the augmented matrix ay upper triangular na yung form. Ito yung main diagonal, yung entry sa ilalim ng main diagonal ay puro zeros na. And now we can do back substitution. Okay? Because remember, ang parang nangyayari dito ay meron kang matrix na to. Pag sinulat muli ito into matrix form, right? Ganito yung magiging itsura niya. Oops. Okay. Tapos mamumultiply siya ng vector of unknowns, x2, x3, x4, all right? Equals whatever the right-hand side is, 1, 1/4, negative 12/7/0. Okay. Ito yung equivalent system that we obtained via elementary row operations. And we know that this is equivalent to the original system in the sense that they share the same solution kasi nga elementary row operations yung ginamit natin. So if you carry out the multiplication, you will see that the last entry, this guy, times this guy, will give us 5/3 x4 equals 0, which easily gives us x4 equals 0. Okay? And then you multiply the third row by the column of unknowns, we'll get 12/7 x3 plus 10/7 x4 equals negative 12/7. At ito yung sinasabi natin na back substitution. Pwede kong i-substitute yung value na na-compute ko kasi yung susunod na equation on a backward manner ay dalawa lang yung unknowns. Alright? So yun yung ginawa ko dito. Okay? Kinuha ko yung equation, naging negative 12/7 yung value. Sorry, hindi pala 12/7. Alright, tama. 12/7. Tama ba? Alright, negative 12/7 to, tapos ito ay magzi-zero, sinubstitute ko sa kabila. So x3 is equal to, 12/7 ng x3 ay equal kay negative 12/7. So that means x3 is equal to negative 1. Tapos back substitution na naman ako. Alam ko na si x4, tapos alam ko na si x3. Yung second row nung resulting augmented matrix will give us this equation in 3 unknowns. Alright? Pero alam ko na si x3, alam ko na si x4. Kaya ko silang i-plug in. Tapos, performing the simple algebra, I'll get x2 equals 1. And ultimately, we do that for the last entry. So we get this guy, 0 as our solution. 0, 1, negative 1, 0. And that is our unique solution to this particular problem obtained via Gaussian elimination. All right? So sorry, super overtime na ako. But on Friday, we will continue this and perform Gaussian elimination to another system. And titingnan natin ano yung problema with the usual Gaussian elimination. Posible pala siyang magka-problema. But disclaimer, nagkakaproblema siya kapag in-implement siya sa isang machine. Kapag mano-mano natin siyang ginawa, as long as the matrix A, the coefficient matrix A is non-singular or non-zero yung determinant niya, we will get the unique solution by using the Gaussian elimination process. Exactly. All right? Pero ibang usapan pag pinagawa na natin siya sa computer. And that's the scenario that we will investigate on Friday. Okay? So guys, do you have some questions? I thought mabilis lang yung discussion, but I was wrong. All right? Kala ko matatapos ko ngayon yung buong module or part 1 ng module, pero mukhang ito na yung magiging module 6, ano? Kasi kailangan ko siguro yung kailangan ko yung Friday para matapos ito. I'm just on page 8 of 21 pages here. But hopefully we can finish more on Friday. All right? So do you guys have some questions for me? So kung wala na, so still good luck on doing your problem set. Just work around it a little bit more. Deadline is tomorrow, so take full advantage of the remaining hours. All right, and then we'll meet again on Friday. All right, bye everyone.
Thank you po, sir.